Alright guys, so here's the next video on this playlist. I want to walk us through performing operations on 2D and 3D vectors, cross product to be precise. So let's get started quickly. If I want to work with 2D vectors, I'll say, on my calculator mode 1. This is the default mode of the calculator. So for me to come to the vector mode of this calculator to be able to perform these operations here, so I'll say mode 8. So I'll dimension my first vector. So it's a 2D vector, so I'll click on 2. It's asking me the coefficient of my I and my j. So this is 3 and minus 4.5. So 3 equals minus 4.5 equals. So I've dimensioned my first vector. I can just say shift vector 3 for my first vector. It gives me my first vector. So shift 5. I want to dimension my second vector now. I'll just say 1. Then I want to dimension vector b. So I'll click on 2 for vector b. So it's 2 dimensioned. So this is minus 2 and 1.5. So minus 2 equals 1.5 equals. So let me check for equals. Now we are safe. So this is minus 2, 1.5. So to dimension for my c, I'll say shift vector 1, 3. It's 2 dimensioned. I'll say 2, 2, 4. 2 equals 4 equals. So for me to look for the cross product, let's say a times c, b times c, a times b. I'm talking about the cross product here, not the dot. To perform operations like this, I'll first of all call my vector a, shift vector 3, my vector a. I'll use this multiplication sign over here if I want to look for the cross product. So I'll use this multiplication sign, then I'll say shift vector my vector c, which is this 5, equals, I get 0i plus 0j plus 21k. So technically this is just more like 21k. So this is the value of the cross product a and c. So if I want to look for b and c, the cross product, I'll say shift vector, my vector b is 4 here. So I'll say times shift vector c 5 equals, this is minus 11k. This is 0 minus 11, so let's just say minus 11k. So to do a times b, I can just say shift vector, my vector a is 3, times shift vector, my vector b is what? 4, equals minus 4.5k. So imagine all the stress I'll have to go through trying to look for the cross product of all this. So I want to do for 3D now. These are 2D vectors. Let's do for 3D vectors. So the first thing to do is to close the calculator to clear all the data on it. So I'll put it on, go to the default mode. This is the default mode of the calculator. So to dimension for 3Ds, I'll say mode vectors 8. So my vector a 1, 3 dimensioned. No, sorry, I'll say 1. So this is 2, 3, and plus 4. The coefficient of my I, j, and k on those 3 axes. So I'll just say 2 equals, 3 equals, and 4 equals. So here's my vector a. I can just say shift vector 3 for vector a gives me the value of my vector a. So for me to dimension for vector b, I can just say shift 5, my vector b, I'll say 4. No. Something is wrong somewhere. Shift vector, I'll dimension for vector b. So I'll come to vector b, 2. How many dimensions? 3. So I'll say 1. Now it's asking me to fix in the values of my coefficients for I, j, and k. This is 2 minus 1 and 2. So I'll say 2 equals minus 1 equals 2 equals. So let's check if we are correct for equals. That's the value of my vector b. So to get the value of my vector c, to program into this calculator, I'll say dim, and this is 1, 1, 2. So my vector c, 3 dimensions. So I click on 1. So this is 1 equals, 1 equals, and 2 equals. So let's say a times c, b times c, and a times b equals. So let's get started. I want to do vector a times vector c, so I can say vector, I'll call my vector a, which is 3 multiplying vector c, shift vector c, 5. So equals, you see, this is 2i plus 0j, so you can just say minus 1k. That is what this implies. So to do b times c, I can just say shift vector, my vector b, which is 4, multiplying shift vector, my vector c, which is 5, equals what? This is minus 4i minus 2j plus 3k. So to do a times b, I can just say, what is a? 3, multiplying b, shift vector b, which is 4 here, equals, so this is 10i plus 4j minus 8k. Can you imagine? See the time we've saved trying to solve all this. See the time we've saved. That's how as easy it is to use the calculator to perform mathematical operations on vectors, cross products. So another video is gonna come after this video, so it's going to still be on vectors. Stay tuned. Thank you.